What's up, everyone? Welcome back to All About AI Tech. Today, we're tackling a big topic, running large language models locally. Now, we all know how awesome LLMs like ChatGPT and GPT-4 are, but using them often means sending your data off to someone else's servers. That raises some serious privacy concerns, especially if you're working with sensitive information. Plus, cloud compute can get pricey. But there's good news. You can run these powerful models right on your own computer, privately and securely. It might sound intimidating, but trust me, it's becoming easier than ever thanks to some amazing tools we'll explore in this video. So, how do we shrink these massive LLMs down to size? The answer is quantization. Imagine it like compressing an image file. You lose a little bit of detail, but it takes up way less space. Quantization does something similar for LLMs, reducing the precision of the model's parameters without drastically impacting performance. This lets us fit these giants into the memory of our personal computers, even if we don't have top-of-the-line hardware. We'll look at different quantization methods, like 4-bit and 8-bit, and see how they affect model size and speed. Now, let's talk about llama.cpp, a game-changing tool for local LLM inference. LLM inference is what we call it when you give your data, a prompt, to the LLM and ask it to respond. This slick C/C++ framework is designed for speed and efficiency. It's lightweight, has minimal dependencies, and works across different operating systems and hardware, including your trusty laptop, even a Raspberry Pi, or even a multi-GPU server if you happen to have one lying around. What's more, it directly supports quantized models, making it incredibly powerful for running LLMs locally. We'll cover how to install and use llama.cpp and how it unlocks the full potential of quantized models. Next up is Ollama, a user-ready tool that makes deploying LLMs locally a breeze. Think of it as a friendly wrapper around llama.cpp. It simplifies the process of installing, managing, and running different models, giving you a cloud-like experience right on your computer, but without the cloud. Ollama goes above and beyond by handling hardware detection and model offloading between your CPU and GPU automatically. Plus, it has its own model library, so you can easily download and try out a bunch of different quantized LLMs without any hassle. We'll get into how to use Ollama and how it makes local AI accessible to everyone, even non-technical users. Now, let's explore some other powerful tools for local LLM deployment. We'll look at frameworks like Hugging Face Transformers, known for its flexibility and large model library, VLLM, designed for low latency and high throughput, and NVIDIA's TensorRT LLM, which squeezes every last drop of performance out of your NVIDIA GPU. We'll compare their features, usability, and performance, giving you a solid understanding of which tool best fits your needs and expertise. Next, I want to dive into something pretty darn awesome, Llama v2. This framework is designed to run local LLMs at lightning speed. It's like giving your computer a shot of AI adrenaline. We'll explore how to install Llama v2 and how it maximizes your performance, giving you near-instant results. Plus, we'll discuss how it introduces a new quantization format, EXL2, which you can use to pack models even more efficiently. Let's talk money. Running LLMs in the cloud can get expensive, but local hosting lets you take control of your costs. We'll analyze the energy costs of running LLMs locally versus cloud-based solutions and see how much you can save by bringing your AI home. It's more than just pocket change, especially if you're running LLMs regularly. We'll break down the math and show you just how affordable local LLMs can be. Privacy is paramount. Running LLMs locally gives you full control over your data, so you don't have to worry about sending sensitive information to external servers. We'll discuss the importance of data privacy in today's world and how local LLMs give you peace of mind. Plus, we'll discuss how local hosting improves reliability by eliminating dependence on external services so you can always access your LLMs, even when the internet's down. Now, what about the programming languages behind all this magic? We'll compare languages like C++, Python, Java, and Rust. Each has its strengths and weaknesses for AI workloads. C++ excels at performance, Python's packed with libraries, Java's reliable for scaling, and Rust adds security. We'll break down how each language contributes to the open-source LLM ecosystem, helping you choose the right language for your coding projects. One common concern about quantization is the drop in model accuracy or quality. We'll discuss how to quantify your quantized LLM's performance. Measuring the perplexity of a model, how well it predicts words from a given text, helps us assess the performance trade-offs of quantization. We'll look at tools like Llama Perplexity and how to interpret the results to find the right balance between compression and quality. The future of AI is local. As models get smaller, hardware gets faster, and tools get easier to use, local LLM deployment is becoming more and more accessible. We'll have local AIs powering everything from smart homes and personal assistants to scientific research and creative endeavors, right at our fingertips. It's an exciting time to be in AI, so definitely stick around to see what's on the horizon. I hope you found this video useful. As usual, I'll post all of the resources I used here in the video description. Be sure to let me know what you're working on in the comments section and consider sharing your quantized models or tools with the community. It helps further democratize this powerful technology. Don't forget to subscribe and hit the notification bell to stay updated on all things AI. I'll be answering as many questions as I can, so leave those comments and let's help each other out and explore this exciting, revolutionary, and fast-evolving space. Thanks for watching.